There are many theories in science that we think are mostly right but not quite perfect. Einstein's theory of general relativity, for instance, is held to be one of the most ingenious out there, but we know it's incomplete. Although it explains a huge amount about gravity and space, it still falls short regarding quantum gravity and singularities, like those that form in the center of black holes. The same can be said about the standard model of particle physics, that it's good, but not quite perfect. It's the most successful framework we have to broadly describe the way our universe works, explaining how all particles link to four fundamental forces: the strong and weak nuclear force, the electromagnetic force, and gravity. The model pitches that these forces are what allow elements to form, and they dictate how particles interact. But the standard model also isn't complete, and science knows this. Despite it explaining three of those four forces extremely well, it has yet to effectively incorporate gravity. It also fails to allow for dark matter, to some degree antimatter, and other important unknowns in astronomy. One of the ways in which the standard model is continually tested is with the help of atom-smashing particle accelerators. These incredible machines, the most famous of which is the Large Hadron Collider beneath the France-Switzerland border in Europe, are used to accelerate beams of particles to intensely high speeds, sometimes getting close to the speed of light under routinely extreme conditions. In general, the matter within the accelerators is propelled to these speeds in order to achieve high-energy collisions, which smash apart protons, or whatever's being tested, into a cloud of different, often rarer, subatomic particles. For science, it's like breaking into the subatomic world. And by watching these interactions, researchers can test predictions and, hopefully in some cases, find new particles. In 2012, the famous detection of the elusive Higgs boson particle, said to be what gives mass to all other particles, was for a time thought to have rounded off the standard model, filling in the last great puzzle piece within it. But now, all confidence is out the window, as new research is threatening to totally upend the model, irrespective of the fact that it's been a cornerstone of modern science for decades. For the most part, the standard model has proven good at predicting things like particle mass, weight, and general behavior, but apparently not this time, after a discovery announced in April of 2022 regarding a particle called the W boson. W bosons are important in physics because scientists think that they, with the help of Z bosons, give rise to the weak nuclear force, the force responsible for radioactive decay in atoms. The paper detailing the discovery, published in the journal Science and relating to a decade-long study by a team at Fermilab in the US, found that the W boson in particular is slightly more massive than would be expected or predicted by the standard model, about 0.09% more massive. And while that may sound a little underwhelming, extreme precision is vitally important in subatomic study, and even the tiniest of variations can make or break a theory. And so, despite the discrepancy being small, the results are statistically significant, implying that something's gone awry. Either the method and measurement or the standard model itself is in error. Particle physics until this point then really could be thought of as wrong. This isn't the first time the W boson has been scrutinized. Researchers first found the boson and recorded its mass back in 1983, and at the time, the data matched what was expected of it. The particle was found to fit within the standard model. Times have changed, however, and the new boson measurement is the result of 10 years' worth of work and countless particle collision tests. In fact, those behind the 2022 study claim that the new measurement is more accurate than that obtained from all previous W boson experiments combined. And while 10 years of analysis toward one subatomic particle might feel like a lot, a member of the project, the physicist David Toback, has reportedly said, quote, "You can do it quickly, you can do it cheaply, or you can do it right," end quote, before claiming that they did it right. It would appear then that in this case, neither the method nor the measurement is at fault, which means only the standard model itself is left wanting. Due to its wide-reaching repercussions, this seemingly tiny W boson revelation has sent shockwaves through the scientific community. There have already been some theories put forward to try and explain the W boson's mass while preserving the standard model, including a suggestion that there could be a problem with how we understand that other poster particle of 21st century science, the Higgs boson. But so far, nothing sticks. To some degree, this could prove to be the first major blow to the standard model since its creation in the 1970s, although it should also be noted that not everyone is quick to completely write it off. At what's still an early stage in science's bid to process what has happened, many are taking the new boson results with a grain of salt, at least until they're confirmed by follow-up tests. A claim as heavy as this certainly requires a lot of investigation before it's universally accepted, and researchers, including those across the Atlantic at the LHC, are already working toward that. But it's expected to take time. W bosons are notoriously difficult particles to pin down for a couple of reasons. First, they rarely appear, with it reportedly taking literally millions of collisions during the Fermilab tests between protons and antiprotons to produce just one of them. But second, they're also extremely short-lived, disappearing before they can even be directly measured at all, as researchers usually have to chart them based on the energy trail that they leave behind. Really then, this story already represents an impressive enough breakthrough based just on the fact that science can now get any kind of handle on these things, when for so long they had been essentially inaccessible. But the discovered discrepancy on top of that makes it all the more important. So what happens next? Armed with and inspired by the new, ever so slightly more massive measurements, scientists will now strive to work out why the W boson doesn't fit with how we thought things should be. What specifically sets it apart? What specifically is lacking with our current model of particle physics? And what do we need to change to improve it? Because although research like this might at first feel like a disappointing result, and although it may make it appear as though science has failed us until this point, it's actually the opposite that's true. Thanks to improved study, we now know that there's more we don't know about the universe. And that paves the way towards opening new doors, bringing in fresh perspectives, and potentially gaining a better, truer grasp of reality than ever before. At the subatomic level, the present perhaps isn't quite what we had previously expected it to be, but the future remains bright. There's a fresh challenge laid out in front of us, and this new research might be exactly what science needs to progress. This one discrepancy could well force physics into developing a new standard model, which could fundamentally improve the base knowledge of our entire species. That's why this tiny measurement is also huge news, because of the wider implications that it could have, because of the changes it could trigger, and the answers it might reveal. What's your verdict? What does the W boson tell us about the wider world around us? Is the standard model still strong enough for purpose, or does this one hole weaken it beyond fixing? The debates are sure to rumble on, and the follow-up tests are already underway. But that's how scientists may have just discovered that particle physics is wrong. In our relentless pursuit for knowledge, there are some questions and mysteries that are much more difficult to decipher than others. And the question of death is arguably the most difficult of all. What really happens when the end comes? Can we ever be completely sure until we ourselves reach that point? These are problems that human beings have always wrestled with. But have we finally been given a glimpse of the truth? Unsurprisingly, there have been countless studies into death over the years, but also, and understandably, there are various ethical considerations which make the business of analyzing and measuring death a little tricky. Death comes to us all, but it's often unexpected, and even in a hospital setting, the focus at the moment of death is usually on trying to keep the dying person alive, rather than recording precisely how death unfolds for them. In February 2022, however, news broke of an accidental recording of a dying brain, which reportedly has given scientists a unique snapshot into a person's final moments. Although details of the recording were released in 2022, the event in question actually took place 6 years earlier in 2016. An 87-year-old patient in Canada was then being treated for epilepsy, which involved doctors taking brain scans to measure his neural activity. However, when the patient unfortunately suffered a heart attack and died during one such scan, it meant that researchers had captured a unique series of moments within his brain, before, during, and after death. With around 900 seconds of brain activity measured in total, analysts were subsequently able to specifically pinpoint 30 seconds before and 30 seconds after the patient passed away. And what they found appeared to support a long-held theory about dying, that your life flashes before your eyes. According to the study, published in the journal Frontiers in Aging Neuroscience, the dying brain showed an increase in gamma activity, releasing brain waves that are ordinarily linked to memory recall. The patterns that were recorded also relate to complex functions such as dreaming and meditation. The suggestion is then that when death arrives, the brain perhaps does embark on the phenomenon sometimes known as life recall, And in the case of this particular patient, it may last for up to 30 seconds after the heart stops beating. Up until now, most of what's known about this comes from the testament of those who have had a near-death experience. The sensation of having revisited key moments from their lives is one of the most often reported by anyone describing an NDE. Scientists have also seen similar gamma surges in the brains of dying animals such as rats during testing. But this latest study offers a unique look at what happens to the human brain. Importantly, those behind the findings highlight that this is still just one case study, and so the results can't yet be applied to every brain. The patient had been diagnosed with epilepsy, which may have affected how his particular brain reacted to death. Similarly, the medications that he had previously taken might have had an effect too. And as no normal brain activity had been measured beforehand to serve as a comparison, it can't be clearly proven that any of the changes in the dying brain were that dramatically different to the patient's standard brain activity. As groundbreaking as this study appears to be then, there are still plenty of questions and mysteries left to be solved. But nevertheless, this study could yet serve as one of the most significant moments in our quest to understand the dying brain, and the human brain in general. For many, the 21st century is shaping up to be an incredibly important period for neuroscience. We've already made important breakthroughs regarding how we understand the senses and how we view the importance of sleep. And thanks to an ever-increasing mass of data, researchers can better than ever before map the brain and identify neurological processes. The human brain is still widely regarded as possibly the most complex single structure in the entire universe, but we've also never understood it quite as well as we do today. The Human Connectome Project, or HCP, is perhaps the most ambitious research initiative relating to the brain overall. A U.S. state-sponsored effort to map the human brain in its entirety. It was started in 2009, originally with a 5-year goal for completion. So massive has the task proven to be, however, that it still hasn't been finished, 13 years later in 2022. The scope of the HCP has grown and grown in that time, though, so that it's now a multifaceted international venture. For example, while part of the project aims to better understand how Alzheimer's disease and dementia take hold, another concentrates on anxiety disorders and how they can be identified by how the brain fires. There are also specific studies looking at the human brain at different points of its lifetime, from infancy through to old age. So while the 2022 Dying Brain study wasn't directly linked with the HCP, we can see how the results of it have hugely contributed to what's become an enormous field of research. But finally, what can we do with the information that the Dying Brain study has provided? Unlike with so many other areas, it's not as though scientists are expecting a wealth of new and supporting data to arrive anytime soon, due to the ethical considerations involved. A doctor can't just simply measure a patient's brain until they die without seriously neglecting their duty for care. And in fact, according to some reports, one of the reasons why it took until 2022 for details to be released of a brain recording from 2016 is because researchers have been trying to find another similar case in the meantime, but without any luck. This one glimpse of the dying brain is an exceptionally rare event then. And while we might expect more examples to emerge as technology improves and evolves, for now it has set something of a new precedent. Until now, the notion of a dying person's life flashing before their eyes has perhaps been treated somewhat skeptically. No matter how many near-death experiences are reported, the apparent similarities between them are often put down to things like stress of the event, misremembering, or confirmation bias. It's said that patients may recall certain aspects of an NDE only because that's what they had previously expected would happen during one. But now there appears to be genuine scientific findings to support the claims. The idea of life recall may no longer be so easily dismissed, as we now know that in at least this one case, the areas of the brain involved with memory recollection were particularly stimulated right at the end of life. Unfortunately, what this study cannot do is stop death in its tracks. The search for immortality goes on across all sectors of science and technology. But one consideration might be whether this latest development will lead to us managing death a little differently in the future. As the Human Connectome Project, amongst other things, seeks to better equip us to fight against various neurological conditions that can affect the human brain, if we're now getting a grip on the brain activity of death itself, then might we soon try to tackle that as well? If not to prevent it, then at least to ensure that when death does come, we can shape how it affects our final moments. Now, perhaps there is some comfort already to be found. Although this remains just one case study, and many of the conclusions to draw from it are still hypothetical, the suggestion is that when we leave this life, we do so in a dreamlike state of memory recall. For one patient, at least, the brain activity during death appeared to stimulate these kinds of reflective, recollective final thoughts. And that's why, to some extent, scientists might have discovered what happens when we die. Or at least they might have discovered a little bit more about one small part of it. But of course, there is still so much about dying that remains a mystery. And there are so many metaphysical questions